This sample problem is going to calculate how to determine the height of a structure given a setup and turning an angle. Just as a reminder, when we're looking at converting between vertical and zenith angles, it will depend on your instrument setup. All zenith angles are taken off of the vertical, whereas all of your vertical angles are taken off of the horizontal. So we will do all of our sample problem calculations based off of a vertical angle, so we will need to convert if we are given a zenith angle. If we have a positive vertical angle, and we need to convert to a zenith angle, what we are looking at is this angle here for our zenith angle. So in order to do that, we need to take 90 degrees minus our vertical angle, and that will give us our zenith angle, whatever it might be. If we have a negative, so if we have our instrument set up, again, off of vertical, for our zenith, off of horizontal, for our vertical, if it is a negative vertical angle, the difference here is that our zenith will run past our 0 for the vertical angle. So here, to find zenith, we would take 90 degrees plus the absolute value of that angle. Now this is important because this will be a negative angle. So another way of looking at it, it's 90 degrees minus a negative angle. Either way, but it will need to be larger than what that angle is, and that is what will give us our zenith angle. So again, we need the absolute value of that vertical angle. All right, so now we can get into our sample problem. The sample problem for this structure is we are given a zenith angle, so we will need to convert it in order to determine our vertical angle. We need to determine the height of a structure, and we have our instrument set up 50 feet away from the structure or the building. The instrument height is 4.5 feet, and the elevation change from the instrument to the structure is a positive 14. You always need to make sure that you are paying attention whether it is positive or negative and which one is listed first. So we are going from the instrument to the structure, so that means that our structure is set higher than our instrument. If it was a negative number, it would be reversed. Again, if we said we're going from the structure to the instrument, we would have to see which direction it is going. But it's very important to help visualize by drawing a picture, so that's the first thing we're going to do. We have our instrument set up. We have our 0 for zenith angle. We have our horizontal for our vertical angle. So again, the angle we are given is off of north. It is our zenith angle. This is 30 degrees, 17 minutes, and 43 seconds. Other important information we have on here, our instrument itself, it is set at 4.5 feet. So that means our instrument is essentially 4.5 feet tall where our actual instrument is on the tripod. So we'll need to know that information. We also know that we have 14 feet for our structure that is higher than our instrument itself. So it's based off of where it is set up, not the top of the instrument. So it's based off of ground where it is. What this means is our base of our structure is sitting at that top of that 14 feet, and the ground itself is a hill that's coming up. So we have essentially a line of sight from our instrument that is in line with this arrow, our horizontal, that we will also need to take into consideration. So we'll look at all those parts and pieces while we're doing this calculation. First step is to convert from zenith to vertical angle. So we need to take from zenith to vertical. So we take our 90 degrees, we subtract out our 30 degrees, 17 minutes and 43 seconds, and we end up with 53 degrees, 42 minutes and 17 seconds. You can type these into calculators. If you're doing it longhand, you can look at it as 90 degrees minus 30, 17, 43. So in order to do this, what we have to do is we have to change our 90 into an 89 degree, 59 minutes, and 60 seconds. Remember, there are 60 seconds in a minute and 60 minutes in a degree. So basically, we're pulling out 1 degree and making it into 60 minutes, then we're pulling out 1 minute and making it into 60 seconds. So that way, when we have our number 30, 17, 43, we can bring the numbers down, and that's where we get 17, 42, and 59 for our answer. So this is our vertical angle that we will be running our calculations off of. We are looking at our trigonomic functions again. So if the height is what we are looking for, and we know that our distance from structure to instrument is 50 feet, what we know is that we are dealing with an opposite and we are dealing with an adjacent to our vertical angle that we just calculated. So we're using our tan function like we've used so many more times. If we want to, we can convert our angle into decimal just to make it easier for typing in 59.7047 degrees. So we can take tangent of that 59.7047 is equal to h1 over 50 feet. You'll notice that h1 is different than h. This is where we need to have a separate height, h1, that goes down to where our extension of our vertical is. The line of sight direct is not plumb and level with the bottom of the structure. So we have to first find our h1 height to be able to determine what our actual height of our structure is. If we run that out, h1 will equal 85.5809 feet. And from there, we see that we have a couple different numbers that we have to take into account. We have our 14 feet from the bottom of the structure down to our inline grade of our instrument. We also have the 4.5 that is from our grade to the instrument level. So in order to go from our h1 to our h height, we first need to add in this 4.5 feet to bring it down to the base level. So add 4.5 feet. And then we need to subtract the 14 feet to get up to the remaining height that's left. You can do this separately, you can combine it, there's multiple ways of doing it, you just need to make sure that you're taking into account which direction you are growing. So we end up with 76.0809 feet, so we have a structure that is roughly 76 feet tall. So that is figuring out where we're going. We can have all different types of structures. Again, it's simply based off our instrument setup. We can have a structure that's actually sitting lower than our instrument itself. It's the same setup, And it just depends on whether or not we have a vertical or a zenith angle, but we can find it and we can take into account, again, the height of the instrument from the grade, the difference between our structure to the base of our instrument, and again, depending on what that distance is, we can do the exact same calculation. So it just will depend on where we're at. And it will then depend how we adjust that final number. So here, our H1, we would actually add both our instrument height setup as well as our difference. So we just need to make sure that we are taking into account, we're drawing the picture first so we can see exactly what it is that we're doing.